Welcome. My name is Joseph Giacomin, and I'd like to talk to you today about a research proposal that I'm making at the current point in time, which is called the emotional automobile. My background, I originally started as a mechanical engineer, moved to design, but all along I've always been interested in humans and in what would be termed today human-centered design. My research track record, 140, 150 publications, something of that order, I lose track. Recently, 4 or 5 books. The books in the most recent times have focused quite strongly on semi-autonomous and autonomous systems, particularly autonomous road vehicles, because we've now reached a point in human history where we're making machines which have levels of complexity we've never imagined previously, and they have behaviors and they take decisions and they have a degree of agency where they decide things and act on our behalf, which has never been the case previously. So we're now beginning to deal with artifacts of design, which in many ways seem more like people or at least animals than they do machines, the traditional machines we were familiar with in the past. So what's the best approach for dealing with these new semi-automated, autonomous, and artificial intelligence-based systems? Well, human-centered design is the natural way to approach the problem. Look at it from the point of view of the humans, the people who will have to interact and deal with it and perhaps encounter it on a daily basis. Human-centered design is a set of questions and activities right from the concept stage all the way to final prototype testing, where you're constantly asking questions about how will the people, the principal stakeholders react to this? What do they think about this? What do they like? What do we know about them? What criteria do we have to design for them? A lot of human factors in ergonomics, a lot of the science of human physical, perceptual, cognitive, and emotional abilities, a lot of what's referred to as user interaction design, UX, or human-robot interaction these days, or HRI, quite a bit of product semantics, semiotics, and discourse analysis, a lot of what are the metaphors and potentially the values and meanings that these different design choices are naturally stimulating in the thinking of the people who use the artifact. And then at the very top of the triangle, meaning. In a world that's rich with products, systems, and services that are very good, that are very cost competitive, very capable, very powerful, very complex, you start to ask more and more the question, which of these things do I value? Which of these are meaningful to me? And the commercial success or the political or the NGO success of initiative these days is quite often determined mainly by how the artifact, how the product, system, or service embeds itself in the life of the people involved, what they value about it, and how it helps them to live in a more meaningful, more deeper manner. So at the very top of the triangle, there is, okay, it works, it's safe, it's comfortable, it provides a good experience. Now, why is it the person wants to engage with it? What does this mean to this group of people who will be engaging with this artifact? So human-centered design spans all of these areas, and hopefully the objective is to achieve a product, system, or service which is intuitive. Intuitive physically, perceptually, cognitively, emotionally. Intuitive, natural, something that's obvious to people so they don't have to work hard and get stressed when they interact with this particular artifact. So what's this specific project about? What's the problem or the challenge? Why are we proposing something like this? Well, the difficulty is we're now producing road vehicles whose complexity far exceeds anything we've ever done before. A typical road vehicle today can have, more than 1,000, maybe 1,600, 1,800 user selectable settings between mechanical adjustments such as the seat or electronic settings for the dashboard or the infotainment system. We are producing machines of a level of complexity which far exceeds what the average typical human being is able to monitor and able to adjust. When the car or the vehicle goes back to the garage for servicing, the computer suggests that maybe less than 10% of the onboard settings were ever accessed by the user from the time of purchase of the vehicle. So we're now adding and adding and adding sophistication beyond what people are able to monitor and adjust. So in theory, these settings and these capabilities are there, but they're not necessarily always exploited in the most efficient manner. How does Mother Nature coordinate living creatures that are very complicated with many components, many parts, many systems, lots of thinking and agency and deciding? Mother Nature gave all living creatures emotions. And the emotion system is a coordination mechanism. It's a priming mechanism to try to get the best out of the complete set of subsystems at any point in time. So the proposal is, given the complexity of today's vehicles, given the foreseeable complexity of the fully autonomous machines of the future, how are we going to coordinate the subsystems and the different components in some holistic manner? Probably we need something that we could label as an emotion system or an emotional coordinating system. The value of the research is to produce targets, to produce criteria, to produce a framework, something we can use from initial concept development all the way through to final testing to see which behaviors the machine should exhibit, which subsystems can or should be involved, and how do we pull it off? What's the sequence of events? What's the coordination mechanism? How do living creatures respond to their environment when they're happy, sad, angry, fearful, and whatever? How do we map something similar, something inspired from that onto the machines we're designing, such that the hundreds and hundreds of components and the dozens of subsystems are somehow centrally coordinated to some degree in a manner that gives some consistency to the response of the machine? That's the value. If we had criteria, possibly a framework for such a thing, could not cover every detail, could not resolve every problem we face, but it gives us something to begin the coordinating with and to look how to connect the subsystems together. The research activities, there's a natural sequence of events. We have to do some reviewing of the animal kingdom, see how living creatures do it, make sure we fully bring on board those that are applicable to vehicles, look at what on the vehicles can be coordinated, which components and which subsystems can actually work together and be brought to do something together rather than independently. Look at the stakeholders, look at people who will be using these vehicles and running these vehicle fleets and see what kinds of behaviors they think would be beneficial given the context and the jobs that they're doing with these vehicles. Make some proposals and do some very preliminary tests to see how people respond to it in the simulator to vehicles that have these characteristics. There's also naturally a management plan. Every 3 to 6 months, there's a set of items of information and a set of criteria which will emerge from that stage of the project. Clearly, these can be summarized and they can be disseminated in steps such that we're benefiting from the research as we go rather than just collecting it on a yearly or bi-yearly or at the very end of the project basis. And of course, these items of information can be tangible deliverables in the forms of presentations and reports, which can be circulated widely within the sponsoring organization to say, here are some criteria, here's some concepts, here's some evidence of things that can be done. What do we think about it? We that are currently designing and building these vehicles, do we see an opportunity here, or there's some challenges that haven't emerged yet, and so forth and so on. And of course, there's a natural cost structure at a UK university in the United Kingdom. The local costs, the local regulations, the local laws need to be respected, and there's therefore a natural set of costs associated with performing the activity. Well, thank you very much for your time and your attention. I appreciate your time. Hopefully, you found this concept of the emotional automobile of some interest to you. The proposal is a very simple one. The machines are now very complex, and they are more complex in many ways than we are. So the proposal is, can we begin to isolate, to gather some ideas, to gather some criteria, put some criteria framework in place for coordinating the many, many components and subsystems of a current vehicle in a manner which is consistent with what humans understand naturally, intuitively, subconsciously. And that manner is what's happening around us in the animal kingdom and with other human beings. We have emerged and evolved to live with other humans and with other creatures. We naturally understand what they're up to and what they're trying to achieve when we see their behaviors. This is about saying, are any of those behaviors, any of those emotions, can they be used to coordinate the various components and subsystems in a way that the vehicle reacts in a way that's immediately obvious to people? So thank you very much. Look forward to speaking with you again in the future on another occasion. Thank you kindly.